pictures you know are the pretty ones, swirls of caramel and cream. A rust-colored eye you have seen since childhood, printed in textbooks and on coffee mugs and lunchbox lids. That version of Jupiter is not a lie exactly. But it is not the planet either. It is a rendering, cleaned up for people who will never go there and will never need to survive it. JunoCam, the camera that produced most of those images, was added to the Juno mission for public outreach. It is not a primary science instrument. Its job is to make you care. It does that job well, and that is part of the problem. When the raw data comes down from the spacecraft, volunteers on the internet enhance the colors before you ever see them. What you are looking at is closer to a mural than a photograph. It has been painted for you. Now look at what those swirls actually are. Wind speeds sustained near 432 kilometers per hour. Not for a season, not for a decade, for centuries. Voyager 1 photographed the Great Red Spot in 1979 and confirmed something quiet and terrible. Those storms are not weather. They are permanent structures with their own smaller weather patterns rotating inside them. Think about that. The most beautiful storm in the solar system has been tearing itself apart in continuous telescopic observation for at least 190 years. Longer than the United States has had electricity, longer than photography has existed, longer than germ theory. Whole civilizations have risen and fallen while that storm kept spinning without pausing for a single day. Beauty is the wrong word. It was always the wrong word. A hurricane on Earth lasts about 2 weeks and destroys entire cities in that time. This one has been going since before your great-great-grandparents were born, and it is roughly the width of 2 Earths side by side. If Earth flew into it, we would disappear inside its outer bands. To understand why beauty is the wrong word, you have to look at what spins underneath. Jupiter radiates between 1.6 and 2 times more energy than it receives from the Sun. Read that again, slowly. The planet is not warmed by sunlight in the way Earth is. It is still cooling from its own formation 4.5 billion years ago, and that cooling generates weather from the inside out. Jupiter powers itself. That single fact reframes everything else you think you know about the planet. At the core, temperatures approach 20,000 degrees Celsius, hotter than the surface of the Sun. Pressures reach an estimated 45 million bars. Earth's atmosphere at sea level is 1 bar. So imagine the crushing depth that broke every deep-sea submarine we ever built, the pressure that snaps a titanium hull like an eggshell at a few kilometers down, and then multiply that pressure by roughly 45,000 times, then keep multiplying by orders of magnitude beyond that. No material we can manufacture survives a fraction of that. Diamond deforms under those loads. Steel becomes irrelevant. Physics itself starts behaving in ways our laboratories can only briefly reproduce with lasers and diamond anvils for microseconds at a time, at costs that only national labs can afford. Somewhere below the visible clouds, hydrogen is squeezed so hard the electrons come loose from their atoms. It stops being a gas. It stops being a liquid in any sense you would recognize from Earth chemistry. It starts conducting electricity like a metal. Metallic hydrogen. A state of matter that does not exist naturally anywhere else in the solar system, and one we have only briefly produced in a lab at pressures we cannot sustain for more than a fraction of a second. Jupiter is not a failed star. That framing is wrong, and it should have been retired decades ago. Jupiter is a working engine of exotic physics, running quietly for 4.5 billion years, and it has never once stopped or slowed. There is no surface, there is no floor. There is no boundary you could point to and call the ground, just pressure increasing until atoms surrender their outer shells. And that engine has a side effect we are only beginning to understand. The metallic hydrogen ocean spinning inside Jupiter generates a magnetic field, not a field like Earth's, which is what protects your skin from cosmic rays right now while you sit still. Something else entirely, something in a different category of phenomenon. Jupiter's magnetosphere extends up to 7 million kilometers toward the Sun. Its tail stretches nearly 1 billion kilometers behind the planet, almost reaching Saturn's orbit at maximum extent. If you could somehow see this field from Earth with the naked eye, it would appear larger than the full moon in the sky. It is the largest structure in the solar system after the Sun's own influence extends outward. And it is invisible. Inside that field, charged particles get accelerated to lethal energies. Near Io's orbit, radiation doses climb to hundreds of times a fatal human exposure. Per hour, not per year, not per mission. Per hour of exposure without shielding. Juno was built for this. NASA wrapped its most sensitive electronics in a 172-kilogram titanium vault, roughly the mass of 2 grown men wearing body armor. And Juno is still degrading measurably with every close pass. Every Peryov takes something the mission cannot replace. The engineers know exactly how many orbits the spacecraft has left before critical systems fail permanently. They designed it to die on schedule, on purpose, because there was no other way. Pioneer 10 flew past Jupiter in December 1973. Its instruments came home permanently damaged, some of them saturated by radiation the engineers had underestimated because the models were still young and the field had never been measured up close. We have known this since before most people watching were born. 50 years of confirmation, and the numbers have only gotten worse as we measure them more carefully with better instruments. Juno is not orbiting Jupiter in any friendly sense of that word. Juno is being killed by Jupiter on a schedule, and every mission planner at JPL knows the exact dose curve down to the week. And that is only what happens to metal. The intuitive fix is to build a bigger ship. Thicker walls, more shielding, more fuel, more redundancy. Send something built to last. A real ship, not a probe. It does not work, and the reason it does not work is arithmetic, not ambition. Radiation shielding does not grow linearly with the protection it provides. Cutting the dose in half does not mean doubling the shield mass. It means adding orders of magnitude more, which means more fuel to move that shield, which means more shielding for that fuel to protect the fuel from the same radiation, which means more fuel still. The design collapses on itself before you reach a survivable dose for any crew. Every engineer who has run the numbers has hit the same wall in the same place. Then there is the gravity well. Jupiter's escape velocity is 59.5 kilometers per second. Earth's is 11.2, more than 5 times harder to leave. Apollo used its entire fuel stack, staged in 3 separate discardable pieces, just to escape the moon and coast home to a splashdown. Jupiter demands a category of propulsion we do not currently possess for crewed vehicles, not a bigger rocket. A different physics of propulsion, one we have theorized about in academic papers but never built at flight scale. And communication. A signal from Earth to Jupiter and back takes 66 to 100 minutes, depending on where the 2 planets sit in their orbits around the Sun. Real-time control is impossible. Any crew there is alone with every decision for the length of a feature film before Houston can even respond to a distress call. Imagine a fire alarm going off in the habitat, and the nearest help is 90 minutes of silence away, and there is no help anyway because no one else is out there. You handle it or you die handling it. A probe surviving 30 orbits is not the same story as a habitat surviving 30 months. The categories are different, not the difficulty. The physics does not reward ambition, no matter how much political will or private money is behind the plan. Now put a human body inside that math. Near Europa's orbit, inside Jupiter's radiation belts, the ambient dose reaches roughly 5.4 sieverts per day. A single acute exposure of 4 sieverts kills about half the people who receive it, even with modern hospital care, IV fluids, bone marrow support, and the best oncologists in the world working around the clock. That is the dose. That is the number the papers keep coming back to. Compare that to real astronauts we already worry about publicly. ISS crew members absorb around 150 to 200 millisieverts across a 6-month rotation, and NASA tracks that dose like a currency, calculating career limits down to the millisievert to protect flight status. Apollo astronauts, on their brief lunar missions, absorb between 1.6 and 11.4 millisieverts total for the entire journey out and back. A Europa astronaut would exceed the entire career radiation exposure of a veteran ISS commander before lunch on their first day in orbit around the moon. Chernobyl liquidators averaged around 250 millisieverts before Soviet authorities pulled them out and classified their medical files. Many of them died young, in their 50s and 60s, from cancers that would not have found them otherwise.
A person standing near Europa in an ordinary spacesuit would absorb that same dose in less than an hour, and that is with a spacesuit built to modern EVA specifications. The consequences are not distant, not statistical, not the kind of risk that shows up in a health report years later back on Earth. Cognitive decline within days, cataracts within weeks that cloud the visor before the mission is over, central nervous system damage that makes decision-making unreliable at exactly the moment when good decisions matter most, cancers that start during the mission itself, not after it, nausea, immune collapse, memory loss, hair falling out inside the helmet in clumps that float in zero-G. The magnetosphere is a room the astronaut cannot leave and cannot survive being inside for long. I am not saying research is worthless.
I am not saying Europa should not be studied. I am saying the body is the argument, and the body has already answered clearly. But radiation is not the fastest way Jupiter kills. Gravity is. In July 1994, Jupiter tore Comet Shoemaker-Levy 9 into 21 separate fragments before any of them touched the planet's atmosphere. Tidal forces did the work at range. This was not an impact event. This was a dismemberment, photographed and confirmed by every major observatory on Earth in real time. The comet was pulled apart weeks before impact, spread out into a chain of luminous beads, sailing toward the planet like a slow-motion execution, watched by every telescope humanity had pointed at the sky. Every mission we have sent has faced that same tidal reach, only smaller and more manageable. Jupiter's gravity at the 1-bar cloud tops is 24.79 meters per second squared, roughly 2.5 times Earth's. A person standing there, if standing were possible, would feel their own weight increase to about 400 pounds in an instant, joints buckling under a body that suddenly hates being upright. Every breath would come harder. Every step would be a negotiation with the planet. But the pull extends outward for millions of kilometers, warping every trajectory that approaches from any angle. Reaching Jupiter orbit from Earth requires between 9 and 15 kilometers per second of delta V beyond low Earth orbit. Juno needed a full Earth flyby and 5 years of transit to arrive at the right speed and angle for capture. It carried no fuel to leave. That was never part of the mission plan. The end of the plan, from launch day in August 2011, was a controlled crash into Jupiter's atmosphere at the end of the science campaign. Count the visitors: Pioneer 10 and 11, Voyager 1 and 2, Ulysses, Galileo, Cassini, New Horizons, Juno. 9 missions across 5 decades of American and international spaceflight. Not one returned a sample. Not one carried a crew. Not one came back. There is no round trip. There has never been a round trip. We have not been to Jupiter 9 times. We have grazed Jupiter 9 times, and every visitor was a sacrifice built into the mission plan from day one. The language matters, and the official language is soft. Read a NASA press release about Jupiter. You will see phrases like challenging environment, extreme conditions, harsh radiation. Careful language, technically accurate, emotionally weightless. Language written by people who need Congress to keep funding the next mission, and who know that a scared public becomes an unfunded public. Now translate. Harsh radiation, in the peer-reviewed literature, means an unshielded human would die in minutes, and their spacecraft would go dark shortly after. Extreme conditions means no material we can manufacture survives contact with the interior at any depth. Challenging environment means the spacecraft is being taken apart by particles while it works, and the mission is a race against how much science it can accomplish before critical systems fail. Look at Europa Clipper, launched October 14, 2024, currently on its way. The mission plan calls for roughly 49 flybys of Europa across the campaign. Not an orbit around Europa, flybys. Why? Because sustained orbit inside Jupiter's radiation belts would kill the spacecraft before the science campaign finished the first year. That flyby architecture is not an elegant design choice discussed in engineering meetings as a preference. It is a confession, written into the trajectory itself, about what Jupiter does to hardware over time. Juno's titanium vault is celebrated in outreach materials as a marvel of engineering, and it genuinely is a marvel.
What is rarely front of frame is how many orbits it is expected to survive before the electronics inside stop responding to commands sent from Earth. The vault does not save the mission from Jupiter. It just delays the ending long enough to collect the data. I am not accusing NASA of lying.
The technical papers are honest and publicly available for anyone who wants to read them. The public copy is optimized for continued funding and continued public interest, which means the hardest sentence in every document tends to land where nobody reads, buried below the enhanced images that make you care about the mission in the first place. Once you see the softening, you cannot unsee it, and it points at something much larger than one planet. Look up on a clear night. Most of what you cannot see, out there among the stars, looks more like Jupiter than like Earth. That is the honest statistical picture as of 2026, and it keeps getting more honest as we find more worlds. Gas giants and hot Jupiters dominate the exoplanet catalogue. Some of that is detection bias. Bigger planets are easier to find with our current instruments because they wobble their stars more visibly and block more light during transits when they pass in front. But not all of it is bias. Jupiter's mass, 318 times Earth's, is closer to the galactic average for a planet than Earth's mass is. Small rocky worlds like ours may be the anomaly in the sample, not the norm we assumed for decades. The comforting story about Jupiter is that it protects us, that its gravity vacuums up comets before they reach the inner solar system, keeping Earth safe from bombardment. The evidence is genuinely mixed on this. Models like the Nice model and the Grantac hypothesis suggest Jupiter has deflected some impactors, delivered others directly into inner orbits, and periodically destabilized the outer solar system in ways that sent debris tumbling inward toward Earth. Our biggest neighbor is not a bodyguard. It is a variable. Sometimes it helps us. Sometimes it does the opposite, over timescales longer than any civilization has ever existed, which means the magnetosphere protecting your skin from the sun's radiation right now, as you watch this video, is a rare configuration in the galactic sample, not a default one. The default, statistically speaking, is closer to what Jupiter shows us. A world where the field is a weapon and there is nothing survivable underneath any part of it. Jupiter is what a planet looks like when nothing softens it. And in the galactic sample, Jupiter is closer to the norm than Earth is by a significant margin, which changes how you see the night sky and how alone we might actually be down here. Add it up. An engine of exotic physics burning from within, still cooling 4.5 billion years after formation. A magnetosphere that shreds electronics and would erase a human nervous system in an afternoon. A shielding math that refuses to close no matter how much mass you add to the equation. A biology wall no engineer can lower with any current or foreseeable technology. A gravity well that keeps every visitor forever with no return trajectory. A public vocabulary that softens all of it into brochure language for taxpayers who fund the next mission. A galactic sample that suggests this is what planets are, and Earth is the exception, not the rule, not the pattern. The Galileo probe is still down there in some sense. Its atoms dispersed through hydrogen it could not survive. It did not land. It dissolved into the atmosphere it was sent to measure. There is no wreckage to visit. There is no grave. There is no marker. Just a location in a spinning envelope of gas where a machine used to be briefly before the planet took it apart at the molecular level. We have not been to Jupiter. We have thrown machines at it, watched them die at varying rates of dignity, and called the death a success because we learned something new before the signal cut out for the last time. This is not an argument against exploration. It is not a call to cancel missions or defund the labs. Europa Clipper reaches the Jovian system around April 2030. The European Space Agency's JUICE mission, launched April 2023, arrives in July 2031. We will learn more, and we should. What we learn will almost certainly be worse than the current model, not better. That is what deeper data has consistently done at Jupiter for 50 years now. Every closer look has raised the numbers, not lowered them. Every generation of instruments has found the environment more hostile than the previous generation of scientists predicted based on the data they had. Jupiter is not scary because it is alien or far away or unknown. Jupiter is scary because it is what a planet looks like when nothing softens it. Not the surface, not the language, Not the pictures, not the press releases, nothing at all.